So, welcome everyone. Thank you very much for joining, and I'll try to keep it nice and short, but very to the point. I'm Matteo. I'm a manager for software engineering at Avanade UK and Ireland, and I'm also Microsoft MVP for Azure DevOps. And tonight, we're going to talk about pipelines as code, because it is something that's been mentioned so many times over the past few years, and now people are really asking, how can we move to pipelines as code, and why should we do it? The reason is simple. Git changed everything in our industry, and it was a massive revolution. It was not just a new version control system, so it was not the new DFPC, it was not just the new SVN, but it completely changed the way that we work on a daily basis. We moved away from centralized version control systems to the new distributed paradigm. But what also introduced is the change to the new role, and the new normal, if you like, in these corona times, is that the new role is as code. So you have infrastructure as code. You hear people talking about configuration as code, and pipeline is no exception, because most of the build engines and release orchestrators, they all support the new pipelines as code paradigm. So if you can store your infrastructure in your repository, and you can store your configuration in your repository, why not storing the pipelines as well, so that you can move around and you can move your repository across Azure DevOps organizations, for example, in a seamless way while bringing all your artifacts with you. So this is a challenge, obviously, because it's a shift in paradigm compared to what used to be the norm, because obviously you know very well the various build and release engines that have got visual interfaces, that have got nice UIs for working on the definitions and making sure that things are easy enough. But in reality, all our favorite stacks are moving there. Azure DevOps, you have pipelines as code. GitHub, you've got GitHub Actions. So pretty much everyone is moving towards this new role of as code, because it's got so many benefits, which we will see in a few minutes' time. It's worth remembering one thing. Nothing of that is new, okay? Because if you were around in the early noughties, you will know that cruise control natively supported pipelines as code. It was 2001, so a little bit ahead of time, I reckon, but it was as code. It was XML rather than YAML, but still the concept is the same. So every other stack at the moment, like I said, all the stacks are moving. Azure DevOps, GitHub, Jenkins, Go CI/CD, Concourse, you name it. Everybody's going there. And obviously, as I'm an Azure DevOps MVP, and I spend a lot of time with Azure DevOps, I can tell you that Azure pipelines fully support them, obviously. If you are familiar with Azure pipeline, then it's worth knowing that the engine is the same. You just have a different way of consuming the pipelines. You just have a different entry point that you can use. But in reality, the experience that you get is going to be the same anyway. And it's extremely good, because it means that there is no legacy and new version to support. There is no difference in how the pipelines are created and executed. You just need to write them in YAML rather than use a GUI. And even that is not really true, because there is some GUI support, and we will see that in a few minutes. Some features are different, though, because the pipeline as code experience has some features which are different or newer or exclusive. So there are things like container job support, which is exclusive to pipelines as code for obvious reasons. And there are things that are only in that implementation because it makes more sense to have them in a as code implementation. Matrices, for example. Build matrices are very complex to set up in a GUI. Pipelines as code is going to be very simple. If you're familiar with Azure DevOps, you will recognize this example. This example over here is the standard example that you get when you want to build a traditional full .NET framework ASP.NET solution. This is literally the example out of the box. The equivalent of this pipeline here in an as code version is this. So you can see that there is a mapping between the various tasks, like use Nugget 4.1, it's over here, effectively. Nugget restore, there it is. Visual Studio Build, Visual Studio Test, publish symbols, and publish artifacts. So you see there is a mapping between things, and we will see that later on. You actually have the same set of extensions, the same set of tasks, and the same set of marketplace possibilities. So it's nothing new. It's just a different facade that exposes different things in different ways. The master branch, the trigger, is over here. You see, it's been ported one-to-one. We are not in front of something new that's going to force you to change everything. And so the question that I usually get, that is, should I migrate today? The answer is no. You don't have to migrate today, because what works today is going to keep working for the next, who knows, 5-10 years. There's no change in there. But you should approach pipelines as code as part of a transformation that you as a development team will face and you as an engineering capacity will face. The other question is often usually, what happens to releases? Because you know that in the traditional experience, you have build definitions and release definitions. With the S code version, everything is S code because pipelines are unified. The new engine is going to run build or deployment jobs independently. There is no need for a distinction between jobs. They are different. We'll see the syntax, but the engine is the same, and there's no more. There's no difference anymore in where you see your jobs. Everything is a pipeline. Support is obviously very wide, so the tools aren't changing. Virtual machines, platform as a service, containers are fully supported. Nothing different there. It's just that you have a little bit of different features, and we'll see all the various edge cases. But the story of pipelines in Azure DevOps is exactly the same. So I'm pretty much done with slides, and there are a few more later on, but the core essence is this. Now let's take a look. Let's take a look at what it takes to move away from a classic pipeline to a full CI/CD experience in YAML. So this is a traditional pipeline. I call it MRP CI legacy. It is a legacy in the sense that it uses the old experience. And as you can see, this is not even an ASP.NET or a .NET application at all, because what I'm doing is using the hosted agent to actually consume Gradle. So this is a Java application, nothing more. And then it runs Gradle for 3 different services with different permutations of parameters. Then it copies files for binaries and deployments, and then it publishes the artifacts. Fairly traditional build definition. And then there's going to be a deployment side, which is pretty much over here. And I mean, at the end of the day, it's a simple stage jobs with, you know, copying a couple of things and running some deployments. So I don't even have the same tasks, simply because I don't have an environment at the moment for this demo. But the concept is largely the same. You're always using tasks. So if we go back to the pipeline, you will see that every step will have a link to see the YAML. And if you click on View YAML, you can easily copy and paste your steps. But at the same time, it can be a long and tedious job to do, because obviously, if you have 50 tasks plus configurations and other things, it's boring and it is low. So you can just get the job. If you pick up the job, you will get all the steps within the job already configured to use YAML. Now let's see what happens if I copy this and I create a new pipeline as code. So I pick up this. Actually, let me go through the pipeline hub, create a new pipeline, git repo. I'll store the repo over here, create a new one. I know it's going to trigger another pipeline as well. It's fine. And I will replace this with the pipeline that I've got. Now, this is not going to work for 2 reasons. The first one is that this pipeline is consuming a different repository. So we need to add a reference to that. And also because this is not the right syntax for the pool. But aside from that, everything else is fine. So if you see that for example, all your tasks over here will have an opportunity to get into their own settings. And that's the same experience that you used to get within your traditional classic Azure pipeline. So that's why I say there is a degree of UI support. Also, because if you want to add any more tasks, all you have to do, instead of going through code and writing it down, if you don't know the syntax to it, then you can add any task that is supported within Azure DevOps. So if you want to add a, let's say, a bash script, then you can add bash, get your inline script, that could be echo world, or it could be anything else, and then you add it over here. That's the bridge between the old traditional UI version of the build and the new one as code. So if we need to add another repository, because if we go back to the traditional pipeline, the legacy one, you will see that we are in pipelines as code and we have multiple repositories within the same project, but it is consuming a different repository than the default one. This is very, very easy to do. All you have to do is to actually add a reference to the different repository. So if we add a few things here. So we have the resource that we want. So we need to define the resources. And then we push in, again, not a container, the resource we're interested in, which is a repository. Okay. So from here onwards, we can refer to every type of repository that we want. It could be another repository in Azure DevOps. It could be a GitHub repository, a Bitbucket repository, you name it. So I will say that I want a repository here. And my repository is going to be, it's going to be of type Git. I need to call it, it's going to be pipelines as code parts MRP. The structure here is simple. Team project, because I'm referring to something that's already in Azure DevOps, name of the repository. And then I need to know what is the, I could add, like for example, a branch. If I want a branch, I could add any other reference. But at this point in time, I don't need anything else, because this is just a reference for my repository. What I'll need to do later on is actually to check it out. So I want to check it out, and this will be called over here. Oh, I need to give it a name. That's right. The reference does that. So the other thing to fix is the pipeline to use, sorry, the agent to use. Now, instead of using pool name and demand like this, all you have to do is to refer to the pool and add a VM image property. Okay, that's all you have to do. Then you can add your demand. Like, for example, I want Java here because, you know, it's a Java project, so I need that. So let me just double check whether I missed something, because we have that as a pipeline as code, but I need to deactivate this for a minute. Oops. So I didn't forget anything, of course. So let me save this for a moment. So if I go back here, I need to, yeah, add the repository. I have the reference to it. So I added the reference to my repository, which I then check out over here. I added the reference to my pool. That's the Windows Server 2017, Windows Server 2016, Visual Studio 2017 with Java. And then all I have to do is to let it run. This is already a CI build. It's going to run on every push to master, and that's by default. So it's simple enough for anyone to move off one system and onto the other. If I run this as is, you can already see that it's referring to two different repositories. The first one, pipelines as code, is the repository that contains my pipeline, because I'm not storing it inside the same repository as the code. And I'm referring to the parcel limited MRP repository as a resource within the pipeline to make sure that I can consume the code and do whatever I need to it. So the build is running. It's running against the hosted DS 2017 agent. And then the first thing is checking out the repository I mentioned before, the parcel limited MRP repository. You can see it's still in the pipelines as code team project, but it's a different repository than the one that's actually used by the pipeline. Takes a little while, and then it's going to kick off the build of the various services and clients. Sorry, with Gradle. Remember that the Microsoft hosted agents, they always have various build engines. So it's not just Azure pipelines per se, but you also have Gradle, you have Maven, you have Ants, you have a number of engines that you can use and that you can leverage to build your applications. It was very, very handy once when we onboarded a Java code base and we had very little ideas about how to actually embed this code base into our solution. So using the hosted agent was a very easy way of getting started and producing binaries quickly. And then we managed to integrate it in a couple of weeks' time within our existing product. So it is running, and obviously, as you would expect, it's going to run Gradle and it's going to do everything over here towards publishing the artifacts. Is there any question up to now? Let's see if I can bring up the chat.
Well, I actually have one question. So you were using DevOps, the website, to edit the pipeline, and I noticed you had that nice IntelliSense, let's call it like that. Do you always do it in the DevOps portal, or do you use Visual Studio Code, or is there any extension for this that you know of?
So if you want the task extension, the task helper, then you need to use this, okay? Because this is the only place where at the moment it's available. But otherwise, I personally use Visual Studio Code a lot. There is an extension for it in there, and everything will be saved into YAML files inside your repository. Okay, so every pipeline definition is effectively just a code file. Okay.
Okay.
So once you get, you get the pipeline up and running, and you compose all the tasks that you want, then they're very easy to maintain with Visual Studio Code. So unless they release the task assistant in Visual Studio Code, then at the moment the task assistant is only there. But I mean, it's something that might always come up. So build is going, and again, if there is any other question on this specific piece, otherwise we can move on. Okay, so the build is green, and as you can see, this is a very simple build, right? It doesn't do anything fancy, it doesn't do anything too complicated. What if you want to move to proper CI/CD? Because at the moment, we only did CI. We didn't do anything CD. So what you need to do is to leverage multi-stage pipelines. So let's do it on the fly, then I will double check it with the other pipeline. But what we need to do is to embed all of this into stages. All right. So if I go on and I add this stages thing here, the initial stage is going to be CI, and then I will have a job. And in the build job, I need to format it. That's unfortunately the worst thing about YAML, having to format it, and sometimes you're just taken off by a formatting error. But at the same time, if you use the portal, you also have this nice validation experience where you can click on validate, and for example, it's going to tell me that at line 50, does something wrong. So if we look at line 50, oh yeah, that's a typical thing. So this is about formatting at the end of the day. And if you want to format it, you either start doing those sort of things and then move on, or what you can do as well is to open up the settings in the task assistant. You paste the same things, and as you can see, it's a formatting error. It's a formatting problem. So you take this out and you move the folder as well. I know it's annoying, but it happens every now and then, and this is a very easy way of fixing it. And then once you select this one up, then you can add it back. And this is obviously duplicated. Right. So that's it. That's how you fix it. And you get the nice validation experience over here. So that's easy enough for anyone without going to other websites and check for the validation of your YAML. And then you can also fix those kind of things with the IntelliSense by just opening up the setting and bringing back in what's necessary. It's dirty. It's not like, you know, the best experience, but it is something that's very effective. And more often than not, if you start having those problems, especially with large pipelines, this is the easiest thing to do. If we add it this way, we now have the same CI build, but within a single stage. So let's do this. Let's save it. And you will see that at the moment, if I collapse it, then I can start adding new stuff. So I might actually have another stage that's going to be deployment to a certain environment. So once you are in a deployment stage, then you have to use a different syntax, which, given that I never remember by heart, I will double check for you. So you need to use the deployment name, and that's the way I will do it, just to copy it from the existing example. The reason why it's different is because this different syntax is going to identify a deployment job. So what used to be a release pipeline in the old experience, in this experience here, then actually do this. What used to be a pipeline here, then it is still a pipeline, still embedded in there, but in a different format and in a different syntax. So you can add as many stages as you like. Let's say I will copy this across as it is. It's going to be even easier. And this specific, this specific experience is designed with the developer in mind. Because what happens is that you will have a developer that's going to start working on their stages, and obviously I didn't format it correctly. They're going to start working on their stages, and they will be able to define everything in a nice and verbose way. So in this case, I'm not doing anything, obviously, in the deployment one. I'm just running the task that I'm interested in. But it's the same story. This is a task. It comes from the Azure DevOps organization. So it's all marketplace stuff or out-of-the-box tasks. Nothing different, nothing new, nothing to change. It can be migrated as a one-to-one. And it is easy enough for everyone, for every developer to pick it up and make it run. You also have new features, like if I put this out as a non-CI build, and I re-enable the other one, which is exactly the same at the end of the day, but it's got a couple of more features. As you can see, I'm enabling that by removing a trigger, and that's a code file. So if I go here and I just do this, easy enough, you see that it's code. I don't have to worry about other tools, other toolkits that I need to embed in, other editors. Everything is code. I'm not bothered. And that's the best thing about this, because it is completely movable and completely transportable between repositories. So the syntax is pretty standard, and you get this kind of experience. So if I re-enable this, what I did here is having a 3-stage pipeline. One of them with a CI build, and given that the other deployment stages are directly connected to the same pipeline file, those stages over here, the dev and the prod stage, will actually download the artifacts directly from the CI build. I broke something, perhaps? Yeah, definitely. Expect the repositories. Okay. Let's fix this. Oh, yes. It's that's it. The joys of formatting code. But at the same time, this is a simple explanation of why it's powerful. I don't have to wait for a long time to actually get the pipeline initialized and then fail. It's a simple failure, but at the same time, it's just transpired very easily and immediately towards the process. Now, the pipeline is working fine, and as you can see, I've got 3 stages. This is a straightforward, straight to production, effectively, type of CI/CD build. But at the same time, it shows you how you can define a stage and potentially make up multiple jobs. So what I usually do is to have a build job in the CI, and add then a test job, and then a package job, simply to keep them separated. And then in the development environment, you can run the actual deployment, and then run integration testing, and then you can run any other type of testing, both security, compliance, and functional. In a production environment, same story. You deploy, and then you can do all sorts of things to it. So it's not just a single job which is contained within a stage. You can have as many stages as you like within a single, as many jobs as you like within a single stage. If we take a look at this, you see that they are simply defined. You see they're simply divided like this, and it's a nice and easy experience. And you can also have parallel jobs running at the same time. You can have all sorts of things going there. What's going to happen here is that after the CI, the CD jobs will start getting the artifacts directly from the build. So let's wait one moment for this. But it is fairly interesting because given that they are connected, you don't need to explicitly call out a download artifacts job. You can do that though, because you might have build and release pipelines that feed from different repositories and different artifacts, and hence different pipelines. So if you have different pipelines that are feeding in a pipeline that's running off a third repository, then you can easily download the artifacts you are interested in. This is the part that takes longer usually because you have to use the Gravel hosted service. But in the meantime, pretending that I need to add the third-party artifacts, all you need to do if you're doing that as part of it, you get in there, say, okay, I need to add another task, of course, and then you make up the artifacts download. You have multiple options, as you can see, because you have all sorts of build engines that are supported. But this is the download pipeline artifacts task. Get it here. You see, if it's from the current run, it's not going to even ask you anything. But if it's from a specific run, then it's going to ask you for the project and the pipeline and the version that you need to use. So you have the flexibility of getting artifacts from different pipelines, and you can compose a runtime as needed. Let's see what's the status. Oh, it started running on the dev. As you can see, test results are surfaced, artifacts that are produced are surfaced, and then once the job starts, the first thing it does is download the artifacts anyway. So this is done implicitly because it is connected to a CI job. It now stopped. So you see, run the command, but it stopped because I have an approval that I need to make. So if I check for my email here, yes, I should have an email saying run stage, approval pending. If I go back here, I will see that my pipeline for prod is waiting for me to approve, because obviously it's a pre-deployment approval. So we don't want to push to prod unless we are really happy with it. I can review what's needed. I can get in there, I can see what this is all about. The development job is this one over here. It's all good. Job is done. It's finalized. Okay, I'm fine with it. And before going to prod, I know that there is a pending job that needs my approval, and it could be a group approval. Okay, it doesn't have to be an individual, so I can approve it or reject it. And as you can see, the instruction is pretty clear that I should really approve this deployment. So I do, and then the job is going to start. Cool thing is that every deployment that you saw me doing tonight, it's actually linked to an individual environment. Okay, so if we pick up the definition again for this pipeline while it runs, these pipelines are actually targeting different environments. So I don't care about the CI now, but the dev stage is targeting a deployment to a dev environment that's called MRP dev, and it is created on the fly. Actually, I could add a third stage here that's going to create it on the fly and potentially deploy. Unless you're targeting virtual machines, for example, you can do that absolutely fine, and you can create everything on the fly with Platform as a Service. With virtual machine, it's slightly different, because if you use tags with virtual machines and environment, then you need to have the environment pre-populated. But once it's done, you can have the whole traceability experience inside the environments hub, so that your environments can be tracked. And as you can see, I have several successful jobs already. If you want to get traceability for your resources, either Kubernetes namespaces or virtual machines, you can do that as well. But aside from that, you have this end-to-end story, because you can pick up the job that was run with the changes that were run, and potentially with the work items that are linked to it. So the end-to-end story is still here. It's very much so. And also, in terms of approvals, for example, that's a brilliant experience, because if I pick up these environments, I already know that I have an approval for deployment on prod, but it's not just approving a deployment. It could be doing a deployment during certain time windows, right? So I want my deployment to only happen on certain days at between certain times. That's very important if you want to prevent deployments when you don't have, for example, an SRE team that's looking after it, or you don't have not just the capacity, but you also don't want to force the team to actually look after out of hours deployments. So unless it's really critical, this is something that can be implemented. You can have branch control, so you can only allow certain branches to actually push to an environment. And that's very important for production environments, because you want to make sure that only certain branches are actually getting up to production. And it's a way of preventing technical debt as well. You can have container images adhering to custom policies. You can have Azure functions or REST APIs that are invoked as part of your pipeline. So whenever you, for example, you deploy something, you might want to invoke a function or an API that's going to check for the status of your deployment. That's something that I do regularly to make sure that before we move on to the next environment, the environment that's just deployed is actually up and running and is actually functioning as expected. So it's like an extra suite of smoke testing that happens as part of the deployment validation. So there are a few of these, and this is quite interesting, the required template. It ensures that the pipeline that's run extends an existing YAML template. We'll see what it is in a moment, but let's see if there is any question right now. I don't see any in the question and answer.
I have a few questions.
Yes.
So one thing that I was thinking is this pipeline as code is a new repo. It's not like a manifest that you have with your side to side with the solution code, your project, right?
Well, no, you can actually store your pipelines within your code repo. The reason why I didn't is because I just wanted to show you the pipeline implementation separately.
Focus on that. Okay.
But
so you can have it side to
this is an
side.
example. Another demo, the parse unlimited MRP. This is the full solution with source and everything. That's the one I'm actually building. And you can see that there is an Azure Pipelines YAML file in there. So that's absolutely fine. You can absolutely do it. This is not the same pipeline that I ran because it was a different demo where I was integrating the two, but you can absolutely do that.
Okay, cool.
It's code, so it goes into your repository.
Yeah, no, I have a certification on Cloud Foundry, and we have this manifest file that works for the deployment. Maybe something can be done to do the CY CD, but we're just doing the deployment so far. The other question was, now that I've seen this, so the other part of the question I want to ask, which was, I already have a project. I want to make my CY CD more agile. What should I do, or where should I go to start this process of getting the pipelines as code, as you're showing here?
Like I suggested, the first thing to do is the moment where you feel confident in migrating, you can see that the pipelines are all grouped together. That's because the engine is the same. There is no functional difference. So you pick up your legacy CI pipeline, you get in there and you start migrating it exactly the same way that I did. So you pick it up, say, okay, I have these tasks. Do I want to do it manually? Yes or no? Can do that. Otherwise, if it's a very big pipeline, you pick up your job, you get the YAML, and you start from this.
Awesome. Thanks.
No worries. Any other question? I saw something. Oh, chat. All right. Okay. So that's the starting point. That's how you move from traditional experience to pipelines as code. Everything goes into a Git repository. Everything goes into the single source of truth for your development team. Now,
sorry to interrupt you. I think Raul had a question there. So Raul, you're muted now.
Rahul?
Hi.
Hi.
Actually, I want to ask a question about that. I want to implement CD. Like, we have a project in which we have CI implemented, but we wanted to implement CD, but it's not fully because the environment is not reachable from our server. But we wanted to implement just the testing part, so that once we implement the CI, it should run the testing and state it is okay to deploy.
Okay. So is your problem just the line of sight towards the server?
My problem is how to implement the testing part, just the testing part, and ensure we get a notification that testing is done. The complete solution is built properly, and the whole testing is done on the build, and it is ready to deploy.
So you can definitely do it by using the Visual Studio Test tasks if you're running against the Microsoft hosted agents, and you can add it to your CI portion. If you want to do it after the deployment, then you need to have an agent on your servers. If they can't reach or can't be reached by the Microsoft hosted ones.
Okay. All right. Thanks.
No worries. So like I said, this is the end-to-end story of moving from traditional to modern, but now there are advanced features. And there are some things which are exclusive to pipelines as code. Container jobs, for example, where the agent is only hosting the container actually running your job. And this is extremely powerful when you have certain support scenarios, for example. That's very, very powerful. And you can have different containers doing different things. Now, we'll see that in a moment, but this is what it looks like, and I will show you what it is in action. So you see the result is this. Templates. Mention YAML templates. We can define our templates so that they can be consumed and populated at runtime. We have loops. So did you ever want to do a for loop in a pipeline? Like you have 5 inputs, you want to do 5 different things. That was not possible with traditional pipelines. Now we can do it. I'll quickly skip to that because I want to show you the demo of that. Matrices. So having a permutation of agents and variables. That's something that was very difficult to do with other build engines. Now it is extremely simple, something like this. Let me show you a few examples rather than just talking through slides. So let's start with container jobs. Container jobs is one of the things that really excites me the most about pipelines as code and Azure DevOps, because this is a very simple job, right? All it does is running a script, a print temp, or it could be anything really. But what I'm interested in is that I'm running against the Microsoft hosted agents, always targeting the latest version of Ubuntu, in this case 18.04. But I want my step to actually run from inside the container, and the container will be running Ubuntu 16.04. So if I run this, we can definitely see that as we go. I'm running against Ubuntu latest, and Ubuntu latest is 18.04 at the minute. So initializes the job, and if I look at the state of the operating system, I know that it's Ubuntu 18.04.5 LTS. So that's the environment. But in reality, I'm not running against this environment, because the first thing that my build does is initializing a container. And this container is Ubuntu 16.04. So from here onwards, the checkout step and everything else will happen inside the container. Now, I don't think this shows the 16.04 anymore. But you see, it runs against an Azure pipeline container. It doesn't run against the traditional agent, traditional virtual machine. And then, once you're done with it, then the container is going to be stopped and it's going to be removed. So you don't have to worry about using an agent. You can just use the agent, Microsoft hosted, that's going to run for you, and then you just initialize your container image. That's the one you're interested in. So you get your actual build environment directly from the container job. And again, this is regular pipeline, so nothing different, nothing fancy, okay? It's just a completely different execution environment. Then you've got other things, like we mentioned the matrix. Matrix is something that's very, very simple to achieve in a pipeline as code configuration. So as you can see, my matrix has got 6 different permutations of agents. I'm not doing anything fancy with them, but I'm just running hello from the image version. The image version is always going to be different, because obviously this is going to be different for every job. So if I run this as is, it's going to take obviously a little while, but you can see that I will have 6 different jobs that are going to be triggered, and those are going to be queued in this case because I don't have enough parallel jobs. But I started with Ubuntu 18.04. That started. It ran hello from Ubuntu 18.04. Then it's going to move on to something else. Let's see, macOS perhaps. Let's see what's going to be the one, or Windows. The Windows is 4. Ubuntu 16 was free before, so now it's 2. This is free. It just says it's going to be macOS. There you go. And this is going to run against macOS. It's running against a Mac. As you can see here, macOS 10.15, and then it runs hello from macOS 10.15, and so on. So imagine you have a support matrix that you need to cater to, each one with his own testing experience and each one with his own testing plan, because obviously that's how support matrices work. That's how you set it up. It's a job that runs usually once, and then you can just scale it up with your matrix as needed. This is extremely powerful, and all it takes is just setting up the matrix itself. So if I look at it, this can be anything then. Okay, this can be any sort of steps that I want to run for each permutation of agents. Every agent will run the same tasks, the same steps. That's extremely powerful. Moving on, let's move to the repo for a minute. We talked about container jobs. We talked about the matrix. The other big experience for me is the if. And the if story, the conditional statements, this is extremely handy because you see how the pipeline is defined. I've got some parameters with two values. Depending on the value that I'm going to pick up, I will have a different experience. So in this case, I have a build definition that has got a Linux version that's going to run, for example, Bash and everything else that's from a Linux version, or I can have a Windows version. So if I'm going to select the Windows version, I'm going to have a different set of tasks that's run against it. Going to the build, I can just run it. Say, okay, if I want Ubuntu, that's going to be run against Ubuntu. But I'm also going to do the same with Windows. And let's see what comes out of it. But you understand that you can switch between different conditions. And in that case, my condition was the operating system version of the pool. So I will default to Ubuntu, but I can select Windows latest as well. If you have a number of parameters, you can build different configurations. And depending on the configuration that you build, you're able to compose what you need with simple if statements. All right? So if we take a look at this, if statements, both done. So this is the one that ran against Linux. As you can see, it's from Ubuntu, and it ran from the hosted agent on Ubuntu. If I pick up the other one, that's the other if statement. Get in here. This is PowerShell, of course, because I run from Windows. And if I check the job, the operating system is Windows Server 2019. Simple stuff, but this makes the difference when you're running at scale. So if you have big configurations and conditional statements to make, then this is very handy, and it saves you so much work because you don't have to write different configurations all the time. The other thing is the template and loop. I group them together because it's a simple example. But if I pick up my template, this is my template. I've got a parameter as an input, which I call param. It's an array. And then for each p in my param array, I just echo p. Looking at the Azure pipeline here is extremely simple. What I do is referring to my template as template.yaml, of course, that's how it's called. And then I populate my parameters. So actually, if I run this with Cork.net, and I also add Azure, simple and straightforward, this is 3 items. The previous run of that build, obviously, this is the CI one that we created before. So the previous run of that build was with 2 items, A and B, as you saw, A and B. If I run this now, exactly the same. I've got different parameters that are invoked. Let me stop this. This is still in my concurrent allocation. There. So now this is going to start in a few seconds. And this is going to run. Yes, started. So this is going to run, and it's going to run 3 steps because I created them on the fly. I say that for every parameter, you just generate a new step. So I could actually have an infinite number potentially of steps because I'm running off a loop. I'm running off a cycle here. And again, Cork.net Azure. I could add as many as I want, and I will get exactly as many tasks coming out of it. Again, extremely powerful because it allows you to cycle through things, and you can have input parameters in there that you can use to populate your loop. Any question? Those are the exclusive, the advanced features of Pipelines as Code.
I have a quick question. The Docker images, where do they come from?
Docker Hub by default.
Okay.
If
Can you override that, or
say again?
Can you override that to get them from your own store?
If memory serves me well, it's possible, but I don't remember that off the top of my head, if I'm fully honest with you.
Okay, thanks.
No worries. So actually, let's check that. I could have. I need the documentation for this. So, no, it can. It also supports ACR.
Okay, that's brilliant. Thanks.
No worries. Any other question? Okay. So before we wrap up, there is one thing that it's very important. Those two systems live together. There's no migration required. They just have different features. So you don't have to start migrating today and leave everything behind. There is no deadline. There is no pressure for actually doing that straight away. So choice is just driven by the preferred approach that you might have. If you have a team that's comfortable with pipelines as code, brilliant. If you have a team that needs time to get up to speed with it, that's good as well, because neither of them are going away anytime soon, and they can work together. If there is no final question, I think we can wrap this up. Otherwise, I'm fairly happy to entertain questions and live demos or anything.
I guess that's a no. No questions.
Okay.
All right, that was brilliant. I'm actually going to send this to our DevOps guy, especially the part about the stages, because we use Octopus and it all feels a bit disconnected between the CI and the deployment. So maybe there's a really good opportunity there.
I see.
Yeah, I would like to thank you again, Matteo, for joining us today and bringing these nuggets of knowledge. As I said, this will be on the YouTube channel, and I'm sure I will see it again and recommend to some people, certainly. So thanks again, and hope to see you soon.
Pleasure for me.
Have a nice evening, everyone.
Cheers.
Bye-bye.